Here on this part we have increasing, decreasing, and constant functions. So a function is increasing an open interval I if f of x1 less than f of x2 whenever x1 is less than x2 for any x1 and x2 in the interval. So here we have this graph. On this part, from left to right, this graph is increasing, meaning that for when x1 is less than x2 in open interval, f of x1 is less than f of x2. So that means our function is increasing on open interval I. Number 2, if function is decreasing on an open interval I, if f of x1 is greater than f of x2 whenever x1 is less than x2 for any x1 and x2 in the interval. So we have this graph here on this part. So from left to right, this graph is decreasing, meaning that for when x1 is less than x2 in open interval, f of x1 is greater than f of x2. So f is decreasing on open interval. Number 3, if function is constant on an open interval I, if f of x1 equal to f of x2 for any x1 and x2 in the interval. So here we have this graph. So it doesn't matter what we have for x. So here x1, the value that we have for y is that point, and that is same for when we have x2. So for x2, again we have same value for y, meaning that for x1 and x2, we're gonna have f of x1 equal to f of x2. That means our function is constant on open interval I. Next part, now here we have intervals on which a function increases, decreases, or is constant. Here examples state the intervals on which the given function is increasing, decreasing, or constant. So here our function is f of x equal to x cubed minus 3x, and this is the graph that we have for this function. Based on this graph, moving from left to right. So here on this part we have this arrow, meaning that here we have negative infinite. Here on top we have arrow again. So it doesn't stop here at this point because of having arrow. So on this part we have positive infinite. So our domain is from negative infinite to positive infinite, and that is same for range. Range is negative infinite to positive infinite. Now this graph is increasing on this part. Again, we have to move from left to right. So increasing on this part from negative infinite to negative 1, this point, and starting from this point, moving to the right, this part decreasing. So increasing from negative infinite to negative 1, decreasing from this point, negative 1, to positive 1, and again increasing from this point, which is positive 1, to positive infinite. Now what we have here on this part, we have this graph. So the functions and equations are not given. The function is defined in 2 pieces. So what we have here, this is open circle. Here we have y equal to f of x. This is closed circle. So we have this part too. Based on these two, on this part, our graph is constant. So it's constant on the interval negative infinite, comma 0. So on this part we have negative infinite up to this point is 0. And the graph that we have on right side is increasing, starting from this point, 0. But it's not equal to 0 because this is open circle. That's why here we have parentheses. It's not bracket. So it's from 0 to positive infinite. So here it says 0, 2, which is this point. That belongs to graph because this is closed circle. But this point, which is 0, 0, that doesn't belong to this graph because here we have open circle. Next part here, we have relative maximum and relative minimum. So we have definition for these two. A function value f of a is a relative maximum of f if there exists an open interval containing a, such that f of a greater than f of x for all x not equal to a in the open interval. The function value f of b is relative minimum of our function if there exists an open interval containing b, such that f of b less than f of x for all x not equal to b in the open interval. So based on this graph, what we have here, when x is b, so at this point, what we have on this part is the value that we have for y is f of b. So the point that we have here on this graph, that is the relative minimum of our function. And the maximum that we have here on this graph is the point that we have here based on x equal to a, and our y value is f of a. So this is relative maximum. Example, use the graph to locate where a function has a relative maximum or minimum. So what we have here on this graph, the maximum value that we can find for y is this point on this graph, and that is x equal to pi over 2 and y is 1. So relative maximum is pi over 2 comma 1. That is pi over 2 comma 1. That is relative maximum, and relative minimum is based on the smallest value that we have for y, and that is -1. So the point that we have here for x-axis is negative pi over 2 and y is -1. So this is relative minimum. So relative maximum is based on our function and what we have for x, f of pi over 2, that's equal to positive 1, and relative minimum is f of negative pi over 2, and that is equal to -1. So the largest value that we have for y is positive 1, and the smallest is -1. Now next part, here we have test for symmetry. definition of symmetry. So the first one that we have is with respect to y-axis. So the graph of the equation is symmetric with respect to y-axis if for every point x comma y on the graph, the point negative x comma y is also on the graph. So this is our graph, and this is x, here is y. So we have this point on this graph, x comma y, and on left side of this graph, here we have negative x, and here is y, so that point is negative x comma y. So we have both of these on this graph. That means this equation, the graph of the equation is symmetric with respect to y-axis. So what we have to do to test for symmetry, we have to substitute negative x for x in the equation, and if we had same equations, or in other words equivalent equations, that means that our graph is symmetric with respect to y-axis. Next one, the graph of the equation is symmetric with respect to x-axis if for every point x comma y on the graph, the point x comma negative y. So here, instead of having negative x, now here we have negative y, because here is with respect to x-axis. So whenever you had with respect to x-axis, you have to substitute negative y for y to see if are you going to have equivalent equations. If you had equivalent equations, that means that your graph is symmetric with respect to x-axis. So here on this part we have x, here is y, and here is negative y. So this is based on, this point is based on these two, and this point is based on what we have here for x and negative y. So both of these points are on this graph. That means this is symmetric with respect to x-axis. Number 3, the graph of the equation is symmetric with respect to the origin if for every point x comma y on the graph, the point negative x comma negative y. So because of having origin, now we have to substitute negative x for x and negative y for y. If we had equivalent equations, that means our graph is symmetric with respect to the origin. So here we have this graph. So this part of graph and this part. And what we have here, we have this point which is based on what we have on x and y. So it's x comma y. And here on this part we have negative x, and here is negative y for this point. So we have both of these points x comma y and negative x comma negative y on this graph. So this means this is symmetric with respect to the origin. Example, determine whether the graph of y equal to x squared minus 1 is symmetric with respect to y-axis, x-axis, or the origin. So first, I'm trying with respect to x-axis. That means that to test for symmetry, we should use negative y instead for y. And if we had equivalent equations, that means that this is symmetric with respect to x-axis. So instead of y, I use negative y and rewrite what we have on right side. So negative y equal to x squared minus 1, or y equal to negative x squared plus 1. So this is what we have here on this part. Now compare this equation with what we had Obviously, these two are not equal. And now, so it's not symmetric with respect to x-axis. Now, working on y-axis. So here again, this is what was given. Now we have to substitute negative x for x. Because of having this power, we're going to have negative x squared, and that is x squared. So what this means, or what we have here is y equal to x squared minus 1, which is exactly the same as what was given. So these two equations are equivalent. What that means, this is symmetric with respect to y-axis. Now, what we have for origin, we should use negative x for x and negative y for y. So this is what is given. And I used negative y for y and negative x for x. So we're going to have negative y equal to negative x squared is x squared minus 1. I isolate y, so divided by negative 1, all of these. So divided by negative 1, negative 1, negative 1. We're going to have positive y equal to negative x squared plus 1. Then compare what we have here, this one, with what was given. Obviously, these two are not exactly the same because of having this negative on this part. So we do not have equality equations. This means this is not symmetric with respect to the origin. So the only one that we have here is symmetry with respect to y-axis only. So this is our graph. This is y-axis. Now we see this one is symmetric with respect to y-axis. If I choose, for example, 2, positive 3, this point on this graph, I'm going to have that point which is negative 2, positive 3 on the other side of graph. Another example, again, testing for symmetry, we have this equation y equal to x cubed. So for with respect to x-axis, here I used negative y instead for y. So we're going to have negative y equal to x cubed. Isolate y, divide by negative 1, both sides. We will have y equal to negative x cubed. Then finally compare what was given with what we have after testing. These two are not exactly the same because of having this negative sign. So this is not symmetric with respect to x-axis. Now for y-axis, here used negative x instead of x. Negative x cubed is negative x to the third power. And then compare these two. Obviously, these two, again, are not exactly the same. Now for origin, respect to the origin, here is what is given. Use negative y instead for y, negative x instead for x. So we're going to have negative y equal to negative x to the third power. Then divide by negative 1, both sides. We're going to have y equal to x cubed. Then compare these two. Obviously, these two are exactly the same. So that means the graph of y equal to x cubed is symmetric with respect to the origin. And this is the graph that we have for y equal to x cubed. For example, if we have this point 1, 1, we will have negative 1, negative 1 on this graph. So both of these points are on this graph. That means it's symmetric with respect to the origin. Another example, we have y to the 5th power equal to x cubed. So that is what is given. Again, with respect to y-axis, we have to use negative x instead for x. So we have y to the 5th power equal to negative x to the 3rd power. And finally, compare the one that was given with what we have after testing. Again, these two are not exactly the same. So this is not symmetric with respect to y-axis. Now for x-axis, we have to use negative y instead of y. So negative y to the 5th power is equal to x cubed. So that means here we have negative y to the 5th power equal to x cubed. So divide by negative 1, we will have y to the 5th power equal to negative x cubed. And finally compare this one with this part. Again, these two are not exactly the same. So our graph is not symmetric with respect to x-axis. And finally, with respect to the origin, we have to use negative y for y, negative x for x. So this is negative y to the 5th power equal to negative x to the 3rd power. And then divide by negative 1. So divide by negative 1. We will have y to the 5th power equal to x to the 3rd power. And finally, compare what was given with what we have after testing. So these two obviously are exactly the same. That means this is symmetric with respect to the origin. Another one. So this is what is given. With respect to y-axis, we have to use negative x for x. So negative x squared plus y squared equal to 16. That is x squared plus y squared equal to 16. These two are exactly the same. What was given with comparing with what we have after testing. So these are exactly the same. This means this is symmetric with respect to y-axis. Now for x-axis, we have to use negative y instead for y. Again, we have, because of having this power, negative y squared, we will have positive y squared. So comparing these two, the one that was given with what we have after testing, again, we have exactly the same result. So that means this is symmetric with respect to x-axis. Finally, with respect to the origin, we have to use negative x instead of x, negative y instead of y. And again, we have same thing. So again, comparing what was given with what we have after testing is exactly the same. So this means our graph is symmetric with respect to y-axis, x-axis, and the origin. So this is the graph that we have. This is circle. So here on this part we have circle, radius is 4. Next part, even functions and their symmetries. So the function f is an even function if f of negative x equal to f of x for all x in the domain of f. So this means our function is symmetric with respect to y-axis. So here we have y-axis. We have to use negative x instead of x. Next one, odd functions and their symmetries. So the function f is an odd function. F of negative x equal to negative times f of x for all x in the domain of f. So this means our function is symmetric with respect to the origin. Neither even nor odd. So on this part, the function f is neither even nor odd if f of negative x is not equal to f of x. So we do not have this one is not equal to, and f of negative x is not equal to negative times f of x. So that means we do not have this part. So we do not have the first and second part for even and odd. So that's why here we said the function f is neither even nor odd. So we have these two for this part. Example, determine whether each function is an even function, odd function, or a function that is neither even nor odd. So here on this part we have f of x equal to x squared. We want to see if f of negative x is equal to f of x. So use negative x instead of x. Here negative x squared is equal to x squared. So these two are exactly the same. For f of x we have x squared, and at the same time for f of negative x we have x squared. So we have equality. Therefore our function is even function. And we have this graph for x squared. And this is symmetric with respect to y-axis. Part B, f of x equal to x cubed. Substitute negative x for x. So f of negative x is equal to negative x to the third power. F of negative x is equal to negative times x to the third power. So what that means, what we have here, f of x is x cubed, but f of negative x is equal to negative x to the third power. So this means f of negative x is equal to negative times f of x, because the one that we have here, this x cubed, is what we had here on this part. This is f of x, but here we have this negative sign, so that is negative times f of x. So that's how we have this part. Therefore, our function is an odd function. Here we have this graph because of having odd function. This is symmetric with respect to the origin. Another example, determine whether each graph is the graph of even, odd, or a function that is neither even nor odd. Part A, we have this graph given. What we have on this part, we have this point which is x comma f of x. Substitute negative x for x, and that is this point, negative x comma f of x. Based on this graph, we can see that this is symmetry with respect to y. Because of having symmetry with respect to y, because of having that rule, what that means, this function is even. Now part B, here is our graph. And what I have on this graph, this is not symmetric with respect to y-axis or the origin. So I don't have anything here on the left side, on the other side of graph. So I cannot say that this is symmetric with respect to y-axis. And also I don't have anything here on this part. If I had this, I can say that that is symmetric with respect to the origin, but I do not. So this means the graph that we have here on this part is neither even nor odd. Now part C, here is our graph. And this is symmetric with respect to the origin. Since this one is symmetric with respect to the origin, our graph is an odd function. Other example, determine whether each of the following functions is even, odd, neither. Then determine whether the function's graph is symmetric with respect to y-axis, origin, or neither. So what is given here on this part A, f of x is equal to x squared plus 6. So use negative x instead of x and see what is the result. So f of negative x is equal to negative x squared plus 6. Negative x squared is x squared. And then compare the one that was given with what we have here. We have exactly the same thing. So it is x squared plus 6 for both f of x and f of negative x. This means f of x is equal to f of negative x. And because of that, we have even function. So this is symmetry with respect to y-axis. Part B, g of x is equal to 7x cubed minus x. Again, use negative x instead of x. So g of negative x is equal to 7 times negative x cubed minus negative x. Negative x cubed is negative x to the third power, and here we have 7, so it's negative 7 times x to the third power plus x, because here we have negative times negative is positive. So this is what we have. Compare these two. We do not have exactly the same thing. But we have different signs. So for g of x, we have positive 7x cubed, but here for g of negative x, we have negative 7x cubed. Here on top, we have negative x, but here we have positive x. So that means we have g of x equal to negative times g of negative x. This means we have odd function, and this is symmetry with respect to the origin. Another example, we have this function x to the fifth power plus 1. Substitute negative x for x, so we have negative x to the fifth power plus 1. So this is equal to negative x power is 5 plus 1. Comparing these two, this one with what I have here, we have on top we have positive x to the fifth power, but here we have negative x to the fifth power. Here we have positive 1, but here we have exactly the same thing. So I cannot say that we have negative times h of negative x. They are not exactly the same, and I cannot say that this is the opposite of what we have on top. So neither of these, h of negative x is not equal to h of x, and h of negative x is not equal to negative times h of x. Note that here on this part we had g of x equal to negative times g of negative x, or we can have g of negative x equal to negative times gx. So it is saying we can just multiply by negative both sides and having what we have here on top. So part C is neither even nor odd. So the graph of h is neither symmetric with respect to y-axis nor with respect to the origin. Now here we have piecewise functions, a function that is defined by two or more equations over a specific domain is called a piecewise function. So here we have this graph based on what is given this word problem. Here this company offers the following plan: $20 per month by 60 minutes, additional time, cost 40 cents per minute. So based on what is given here on this part, we can have our piecewise function. The C is for cost and T is for time. So if time was between 0 and 60, and this is equal to 60, because here it says $20 per month by 60 minutes. So this is $20 for maximum 60 minutes. We cannot have equal to 0 because time is not 0. And then for additional time, which is more than 60 minutes, we have $20 plus 40 cents times what we have for more than 60 minutes. So our time minus 60 multiplied by 40 cents. So that is our piecewise function. And this is our graph for when time is this part from 0 to 60. Again, it's not equal to 0. From when time is greater than 0 and less than equal to 60, cost is $20. So this one, C of T, that is cost based on what time is. And here, this one is time. So for more than 60 minutes, we have this part of graph. So it's $20 plus 40 cents times T minus 60. It's asking to find the following using this function. So finding cost when time is 45 minutes. So time 45 minutes. 45 is in this interval, so that means our cost is $20. Part B, time is 60. Again, we can find T equal to 60 here in this interval, meaning that again, cost is $20. Now here on this part, time is 90, which is greater than 60. So it is greater than 60. Finding cost, we have to use this part. So it's $20 plus 40 cents times t minus 60. Our t is 90. So 90 minus 60 is 30 minutes times 40 cents plus $20. So we're going to have 20 plus 12. We have to multiply this part first and then add 20. So cost is $32 when time is 90 minutes. Now here, this example graph the piecewise function defined by what we have here when x is less than or equal to -1 over f of x is 3. When x is greater than -1 over f of x is equal to x minus 2. So for all x values, so when x is less than or equal to -1, -1 is here, and less than is this part. What we have for y value is +3. Because of having this equal sign, we're going to have closed circle. So for -1 we have +3, for -2 we have +3, for -3 we have again +3, for -4 we have +3. So for all these x's we have same value for y. So draw this horizontal line and use arrow, because this doesn't stop. It's just from -infinite to -1. And that is closed circle, so we have to use bracket instead of parentheses. And so this was for when f of x equal to 3. Now f of x equal to x minus 2. We have to use values for x. So I'm starting with what is given here on this part, -1. So -1 and all x values that are greater than -1. We only need some points. We don't need too many because this is a straight line. We can only have 2 points, but I have 4 points here. So I use -1, 0, 1, 2. So using these numbers instead of x, and find f of x or find y. So these are ordered pairs. Finding these and graph. So we have -1, -3 is this point. But the point is we do not have equal to on this part. That's why here is open circle. It's not closed circle. So it is open circle because we do not have equal to here. And then 0, -2 is this point. 1, -1 is this point. 2, 0 is this point. Connect all these points and use arrow. So what we have here, our domain is starting from left to right. Our domain is what we have on x-axis is -infinite to +infinite here on this side. And our range is what we have on y-axis. So domain is -infinite to +infinite. And our range is, see what you have on y-axis. Starting from this point, we have -3. It's not equal to -3, so we have to use parentheses. And on top, the largest number that we can have on y-axis is this point. based on this graph, that is positive 3, and that is closed circle, so this is bracket. On homework assignment, you may have something like this. So set -3, +3. So depending on how it's asking you to write. And this part, functions and difference quotients. Definition of difference quotient of a function. Here we have this expression f of x plus h minus f of x divided by h. H is the denominator, and we cannot have 0 in denominator. If we had 0 in denominator, we're going to have undefined, so h is not 0. This is called the difference quotient of the function f. Now here, example, we have this function given. It's -2x squared plus x plus y. It's asking to find and simplify each expression based on what is given for part A. Part A is asking to find f of x plus h. That means instead of x, we have to use x plus h. So we have -2 times, here we have x, and instead use x plus h. Here again we have x, so instead use x plus h. And then simplify. So we have x squared plus h squared plus 2 times x times h. You can find your answer that way if it's hard. Instead multiply this way, x plus h times x plus h. So multiply this way and simplify. You're going to have same thing. And then use distributive property, multiply -2. So -2 times x squared, -2 times 2xh, -2 times h squared. Then plus x plus h plus y. So this is the final answer. And part B is asking to find f of x plus h minus f of x divided by h. The one that we had here on this part. The one that was called difference quotient of the function f. So we have f of x plus h from part A. So this part, use that one here instead of f of x plus h. So that part. And then we have to subtract f of x. So f of x was given, f of x as -2 x squared plus x plus y. But here we have to subtract. So this means we have to use distributive property, negative times -2 x squared, negative times positive x, negative times positive y. So we have these. Now combine like terms. So we have -2x squared, and here we have 2x squared, so this part is 0. Then we have -4xh is here. We have -2h squared. We don't have like terms for that one. Then we have positive x, negative x, so that part is 0. We have positive h, we have positive 5, negative 5, so that part is 0. And divided by h, we cannot have 0 in denominator. So we have to see if are we able to eliminate what we have in denominator. Here on top we have h in common between all these three terms. So factor of h, we're going to have h times negative 4x minus 2h plus 1 divided by h. Now cancel h. So the answer is negative 4x minus 2h plus 1. H is not equal to 0. Here we don't have denominator. So if you didn't write that part, that is fine. The final answer is negative 4x minus 2h plus 1. Okay, so this was the final answer for this part.